Chapter 3 talks about water. Clearly, water is an incredibly necessary resource for life to exist on our planet, and as such, the authors of your textbook have decided to dedicate a chapter solely to discussion of water and its unique properties. So first of all, water is the biological medium on Earth. Water essentially covers just about 75% of our Earth, and this sort of three-quarters theme is followed through life pretty much anywhere you look. So your body is about 75% water. Cells are anywhere from 70 to 90% made out of water. So clearly water is very abundant and very necessary to maintain life on our planet. Water is also unique in that it's the only common substance to exist in all three states of matter, a liquid, a solid, and a gas, naturally on the planet. In chapter 2, we also talked about the structure of the water molecule, which we will review in this chapter, but it is this structure of the water molecule that allows it to very easily interact with other molecules in its surroundings. And what we're going to do once we reintroduce the molecular structure of water, we're also going to start talking about some of its unique properties that help it sustain life on our planet. So let's review a water molecule first of all. So in chapter 2, we talked about how molecules are created when atoms are held together using covalent bonds. So clearly, water has to be held together, at least the atoms in the water molecule have to be held together using covalent bonds. The molecular formula for water is H2O, indicating that there are 2 hydrogen atoms and 1 oxygen atom. These covalent bonds that hold the water molecule together, again, are called polar covalent bonds. This is because those electrons that are being shared between the oxygen and the hydrogens are not being shared equally. If you'll recall, oxygen is a fairly electronegative element, and so when it does share electrons with other substances, it tends to hoard those electrons towards itself. Therefore, that results in unequal sharing of the electrons, aka a polar covalent bond. This is also what makes a water molecule a polar molecule. It causes a slight charge separation in the molecule as a whole, and one side of the molecule, where the oxygen is, that molecule develops a partial negative charge, and then the opposite side where the hydrogens are, that side develops a partial positive charge. And you can see this clearly if we take a look at this central water molecule. Here's the oxygen, electronegative, hoards the electrons towards itself, develops that partial negative charge, and then the hydrogens develop the partial positive charge. Because water is a polar molecule, it can form hydrogen bonds with other nearby water molecules. So in this particular image, it's showing you the maximum number of hydrogen bonds that can be formed between one water molecule and other water molecules. So you can see that that center water molecule can make up to 4 hydrogen bonds with other water molecules. You'll notice 1 hydrogen bond right here that's formed between the partial positive hydrogen of the center water molecule and then this top water molecule. The oxygen within that center water molecule is very large. It can actually form 2 hydrogen bonds with 2 different water molecules here. And then the last hydrogen of that center water molecule with that partial positive charge can form that hydrogen bond with that remaining 4th water molecule. So now that we've reviewed the structure of a water molecule, we are ready to talk about some of the properties that water holds that helps it maintain life on our planet. And these properties include cohesive behavior of water, the ability to moderate temperature, expansion upon freezing, and then lastly, versatility as a solvent. Now, 3 out of the 4, actually, the very first 3 of these properties have everything to do with the fact that water can form hydrogen bonds with other molecules. The last one is more so a result of the fact that the water itself, the water molecule itself, is a polar molecule, and it has this charge separation, and that charge separation, those charges can be attracted to other substances that also carry a charge. So let's take the very first property, cohesive behavior, and talk about that one. So cohesive behavior of molecules of water, that pretty much just says water is sticky. And it's sticky because water molecules can form hydrogen bonds with other molecules. Collectively, these many hydrogen bonds that water molecules make with each other is a phenomenon that's called cohesion. This primarily means that because of those hydrogen bonds, water molecules like to stick together. So if you think about taking maybe a droplet of water and putting it on wax paper, for example, right? That water molecule isn't, so if this is my wax paper, right, all of the water molecules they're not just going to spread out on the surface of the wax paper. No, what happens is you have your wax paper and then you take that droplet of water, put it on there, and it creates a nice little bubble. And this means that even though gravity's pulling on those water molecules, the water molecules really want to stick together, and so they form this little bulge on top of that wax paper. So cohesion means water likes to stick to itself. Now, not only is water sticky with itself, so water molecules like to stick to each other, water can also stick to other substances. This is a phenomenon that's called adhesion. Essentially, adhesion is the attraction between two different substances. But if we were to take water into consideration, in lab, we talked about how it's difficult to measure water in a graduated cylinder. Right, and there's a reason for this. So there's my graduated cylinder. The reason why it's difficult to measure water in a graduated cylinder is because you have that thing called a meniscus, right? You pour the water in there and it creates this nice little dip at the top of where the top of the water level is. And of course, right, if your graduated cylinder measures 45 milliliters there and 44 milliliters here, you always want to measure from the bottom of the meniscus, so in this case I'd have 44 milliliters. Well, the whole reason why the water creates that meniscus is because it's sticky. It sticks to the sides here of the graduated cylinder, creating sort of that dip in that level of your water. All right, where would cohesion and adhesion be important in life? Well, plants are a really good example that utilize the cohesiveness, the stickiness of water molecules. Both adhesion and cohesion are required for pulling water from the roots of a plant all the way up to the top of a tall tree, for example. So take a look at this video.
How does water get from the roots of a tree to its leaves? The evaporation of water from leaves moves water molecules up from the roots. The evaporation exerts a pull that is relayed downward along a string of water molecules from leaf to root. Hydrogen bonds cause water molecules to stick together, a phenomenon called cohesion. As each water molecule evaporates, it pulls on the next water molecule, and it pulls on the next. This relays the pull of evaporating water molecules all the way down to the roots. The cohesion of water helps to keep gravity from pulling the water molecules back down.
Okay, so in this video, we see both cohesion and adhesion. So the cohesion of the water molecules, if you take a look at this blow up here inside one of the veins of the plant, this dot dot dot, the hydrogen bond between this water molecule and this water molecule, that's an example of cohesion. But you'll notice that this water molecule is also sticking to the side here of the vein of the plant, and so that would be an example of adhesion.